All right, today we're going to look at transformations of exponential functions and then transformations of logarithms. Not much different than transformations of polynomials. Stuff that's on the outside is vertical. Stuff that's inside is horizontal. If it's added or subtracted, it's a translation. If it's multiplied, it's a stretch or compression. If there's a negative, it's some type of reflection. So that's kind of what this first slide is showing you. You got at the top here, vertical translation, f of x plus k. When you look over here at the examples, if the plus is at the very end of the exponential, you have 2 to the x plus 3. It goes 3 units up. If the minus is at the end, it goes down 6 units. Now the second one, the horizontal translation, is inside the parentheses. And remember, inside's insane, so think opposite. So for instance, inside on this one, you're not going to see any parentheses with exponentials. Inside would be up in the exponent. That one you see x minus 2, so it goes 2 units right. This one you see x plus 1, that means it goes 2 units left. Okay, so in the exponent, that's inside, that's horizontal, you think opposite. Next one, vertical stretch. It's vertical because the number being multiplied is outside. It's a stretch or compression due to multiplication. So this first one, that 6 is outside of a parentheses with 2 to the x. That's a stretch, vertical stretch, by 6. If you have a fraction out there like 1/2, that's a compression by a half. Again, this is all review from last week. Now, horizontal stretch or compression is going to happen in the exponent. Horizontal's inside, with exponentials, it would be in the exponent. And remember, you think opposite. So this first one has 2, and the exponent is 1/5 times x. Usually you would think that's a compression, but since it's horizontal inside, it's a stretch by 5. So you flip the fraction. Likewise, 2 to the 3 times x. 3 is multiplied in the exponent. So again, as I was saying, when the 3 is multiplied in the exponent, you have a compression by 1/3. Again, you have to flip the fraction. Last thing we have is a reflection. These negatives cause your reflection. If the negative is in the front, it's across the x-axis. If the negative is in the exponent, it's across the y-axis. So keep all those things in mind as we go through these notes real quick. Now, example 1 says, using your graphing calculator, graph the function that's given. Now, before we do that, I want to make sure that we can see the comparison. Okay, so we're going to go ahead and type g of x into y1. So go to your calculator, go to y1. We're going to type 2. You're going to hit the caret button, which is above the division symbol. And in the exponent, you're going to put negative x. Well, based on what we just learned, that's a negative in the exponent, so that should be a y-axis reflection. We'll see if that happens. Hit over to the right 1 and put plus 1. Again, that plus 1's at the end. It should be a vertical translation up 1, or you can just say shift up 1. All right, and then hit the table. So hit second table, and let's look at the points that we can plot. I see that we can plot the point, let's see, -3, 9, so go left 1, 2, 3, and up 9 spots. We can plot -2, 5, I go left 2 and up 1, 2, 3, 4, 5 spots. -1, 3, so left 1, up 3. 0, 2. And then we start getting a little smaller. We got the point 1 and 1.5. 2 and 1.25, 3 and 1.125. So what's happening here is we're starting to flatten out, and it looks like we're starting to flatten out right here at this point where y equals 1. If you look at the picture on your calculator, it ought to show up in blue right through here. So our asymptote for graph G here, this is the G graph, should be at y equals 1. That asymptote is related to that vertical shift up 1. Now, part B says, tell how the graph is transformed from f of x equals 2 to the x. All right, so here's the deal. Up here in the exponent, we have a negative. So negative is a reflection. If it's in the exponent, if you look back at the page before, the negative in the exponent is a reflection across the y-axis. So we would say right here, for the first thing that is happening is a y-axis reflection. All right, and then we look at the back end, and there's a +1 at the very end on the outside. If you look back at the page before, when something is added at the very end, you go up. So you have a vertical translation. So our second transformation is a vertical translation, or you could say shift, and it's going up 1. Now, if we wanted to check those, go back to your graphing calculator, hit y equals, leave the g function in y1 and go down to y2, the red one, and type in 2 to the power of x and hit graph so you could actually see the difference. That function does something like this, I believe. And you can see them flipped across the y-axis, and it's moved up 1 because the asymptote for this red one I just drew is at 0, and the asymptote for the blue one moved up to 1. Okay, so it flips across the y-axis, and it's a vertical translation up 1. You could always check it in your calculator. All right, let's move on to the next example. Again, this one wants you to graph and identify the asymptote and then tell the transformations. So in y1, you could leave 2 to the x in y2 if you wanted to, but in y1, we're going to change that one to 2, hit the caret button, and up there in the exponent, we're going to type x minus 2, and we can hit graph. Looks to me like the asymptote is on the x-axis, which would be at 0. If we made our table, though, we could actually see, let's see, at 2, we have a point at 2, 1. We have a point at 3, 2, at 4, 4, at 5, 8. And then before that point 2, at 1, we have a point at 0.5. At 0, we have a point at 0.25. At -1, at 0.125. So we can see right there that our asymptote is at 0. It starts flattening out right there near 0. So to identify the asymptote, we would say it's at y equals 0. Now, part B is tell how the graph is transformed from f of x equals 2 to the x. The only difference here is up in the exponent. You have an x minus 2 inside the exponent. So if you look back, I look for stuff inside the exponent. Here it is right here. 2 to the x minus 2 goes 2 units right. Inside the exponent is a horizontal, and it's a translation because it's subtraction. So the only thing we have here is a horizontal translation. And we think opposite when it's horizontal. Since it says minus 2, that means we go to the right 2 spots. If you left the graph of 2 to the x here in y2, you ought to be able to see that your blue graph goes to the right. Because the other one looks like this. It's -3, 0.125, -2, 0.25, -1, 1/2, 0, 1, 1, 2, 2, 4, and then 3, 8. So you can see all these points. Between these points, you got 2 spots to the right. That graph looks something like this. They have the same asymptote. All right, move to example 3. Example 3 has g to the x equals 2/3, and now that's on the outside, so that's something vertical, times 1.5 to the x. Okay, 2/3 times 1.5 to the x. So we got 3 different things we're doing here. The first thing is to graph the function. So let's go ahead and put it in. All right, we'll clear out y1 and y2. Clear them both out. Now remember, to get that fraction of 2/3, you're going to hit math, go left 1, hit enter, type 2/3, parentheses 1.5, and hit the caret button, raise it to the power of x. To graph it, make a table. Okay. So let's see if I got some things I can draw here. There's a point at 1, 1. Ooh, there's a lot of decimals. It's okay though. There's a point at 2 and 1.5. There's a point at 3 and 2.25. 4 and 3.75. 5 and 5.06. Oh, excuse me. That one at 3 is 3.375. So that would be right in here. 6 and about 7.6. And the point at 7 is at 11 something. So if we go back at 0, we got a point at 0.6667. At -1, we have a point at 0.444.
Are you doing territory?
Mm-mm. So we can see that it's really starting to level out there at 0, because at -2, the point's at 0.2 something. Okay, so we could go ahead, connect those dots, and see our exponential. If you look at the picture, you ought to be able to see that the asymptote is at y equals 0. All right, so we graphed it. There's a check. Part B says find the y-intercept and the asymptote. Well, the asymptote is probably the easiest. The asymptote is at y equals 0. Now the y-intercept, remember, for the y-intercept, the x value has to equal 0. So if you go back to your table, when x is 0, the y value is it says 0.6667. Okay? So you'd write it as a 0, comma, and really 0.6667 is 2/3. But you could also write 0, comma, 0.67. That would be okay too. All right? As long as you know that the y-intercept is where x is 0, that's fine. Asymptote's y equals 0 because it never touches. Now, C, tell how the graph is transformed from the graph of its parent function, y equals 1.5, and that should actually say, so go ahead and add this for me, 1.5 to the power of x. Okay, so we're going to figure out how it was transformed. The only thing that's different is this 2/3 in the front, and it's outside, so we know that it has to be vertical. All right, and it's attached to the outside with multiplication. So multiplication is either a stretch or compression. If you look back at the chart, we're talking about vertical, it's multiplied, so it's either stretch or compression. When it is a fraction, it is compression. So for this one, we need to write down vertical compression by 2/3. Okay, that's the only thing that's happened. Everything else has one. There's a 1.5. There's a power of x. All right, let's look at example 4. All right, example 4, the g function is 2 times 2 to the negative x. So there's two transformations here. There's one on the outside, so that's going to be something vertical. And there's a negative on the inside because it's in the exponent. First thing we're going to do is graph the function. So go ahead and type in y1, 2, parentheses, 2, raised to the power, negative x. All right, so you got it typed in your calculator. Let's look at the table first. Okay, so we'll go second graph. Let's see. Looks like we could start at negative 2. Go to negative 2 up to positive 8. Graph it blue. Negative 2, positive 8. Negative 1, positive 4. 0, 2. 1, 1. 2.5. 3.25. You can see what's happening again. It's getting really close to 0, but not touching it. So y equals 0 is going to be our asymptote. All right, so we got it graphed. So let's look. Let's start with the asymptote. You can see that it should be at y equals 0 because that blue line never touches the x-axis. Again, the y-intercept, we're looking for where x is 0. So we go back to you look at the chart, the table, and there's a point where x is 0, the y value is 2. Okay, and you can see you already plotted that point. It's right here on your graph. Now, tell how the graph is transformed from the graph of its parent function. So if you look at this, the parent function would be 2 to the power of x. This 2 to the power of x. So there's some stuff done to it, and we already wrote it down. This 2 out front, it's being multiplied. It's outside, so it's multiplication. And the negative inside the exponent. So that 2 on the outside is a vertical stretch because it's a whole number, not a fraction, and it's outside. Vertical stretch by 2. The negative inside the exponent is a y-axis reflection. Again, if you wanted to look at the picture, graph this parent function. Go to y equals, put it in y2, 2 to the power of x, hit graph, and you ought to see it. I'm not going to draw it exactly, but it ought to come up through here like this. So you can see that the blue line is on the other side of the y-axis from the red line. So it was a y-axis reflection. Now let's move to logarithms. Now, when you talk about logarithms, their transformations are more similar to the transformations of quadratics. Same concept. Stuff on the outside is vertical. Stuff that's added is a translation. So, for instance, here, plus 3 is up 3. Minus 4 at the end is down 4. Stuff on the inside, like right here, that x minus h is inside. It's horizontal. Since it's minus, it's a translation. Minus goes right. Inside, insane. Think backwards. Plus goes left. Think backwards. Same concept. We just talked about it in the next set. Stuff that's vertical is on the outside. If it's multiplied like that a is, you have a stretch or compression. Okay. If you have a whole number like 6 right here, it's a stretch. If you have a fraction like 1/2, it's a compression on the outside or normal. Okay. If you look at the next one, it's got multiplication inside by a fraction or a whole number. So it's horizontal because it's inside. It's stretch or compression because it's multiplication. If you have 1/5 multiplied inside, that's a stretch. If you flip the fraction, that's how they got 5. If you have 3 multiplied inside, that's a compression. Flip the fraction, that's how they get 1/3. And reflections, just like before, outside, x-axis reflection, inside, y-axis reflection. All right, so let's look at these logarithms. First thing too, if it ever asks you for an asymptote with logarithm, remember it's x equals, because the logarithm's asymptote is vertical. So we're on example 5. It says graph each log, find the asymptote. So when you find the asymptote, remember it's going to be x equals something. Describe how the graph is transformed from the graph of its parent function. All right? So the parent function here is going to be this. I'll write it as f of x. f of x equals log x. All right, now, for these, if it doesn't have a base, these logs don't show a base, you can use the button on your calculator on the left-hand side right next to 7 that says log, because that's the log base 10. All right, so let's graph this function right here, this g of x function. All right, so let's go y equals, and we'll go 5, and then we're going to hit the button that's next to 7 that says log. And we're going to put x and close the parentheses. All right, that's the only thing that needs to be in there. And then we're going to press minus 2. Okay, that minus 2 has to be outside the parentheses. And then what we would do from there is make a table. So we go second graph. And you can see in the table that -5, -4, -3, -2, -1, 0 all have errors. Okay, so if you were to look at the table of x's and y's, the last number with an error is 0. That 0 right there has an E. So that means our asymptote is going to be x equals 0. And if you continue to look at the table, you got a point at 1, -2. You got, let's see, let's scroll down, find another. You got a point at 10, 3. So 10, 1, 2, 3 is over here. So this is obviously moving from this point to this point and coming down. If you want to plot some in the middle, there's a point at 5, 1.5. So if you want to give yourself a spot in between those two to draw. But what I would do next is I would look at the graph. Okay, we've already determined that x equals 0 is the asymptote, because that's the last place in the table where there was an error. So if I'm going to connect these dots, I'm going to come down, 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 and then it's just going to get pretty much vertical. All right, so we've graphed it. Find the asymptote. Well, here the asymptote is x equals 0. That is our asymptote. Then it says describe how it was transformed. Well, you got two things going on here. You got a 5 on the outside being multiplied, and you've got a 2 outside being subtracted. So both of the items are vertical. The first one is a vertical stretch because it's being multiplied and it's a whole number. Whole number is stretch. Vertical's outside, and it would be by 5. The second thing that we have is this minus 2 at the end on the outside. It's still vertical because it's outside. But now it's a translation or shift because of the minus, and it goes down 2. Okay. If you wanted to see that, go back to y equals, and then y2, type in this log x. So I could type log x, hit graph, and I ought to see, hang on, I ought to see my red line 2 spots above. Okay. Now, the one thing you're not going to see, it does look like at one point that the red line is a little flatter. Like it comes right through here, but then it flattens out. And the reason for that is because your blue line has also been vertically stretched. So that blue line's been pulled up. But between these 2 points right here, there's a vertical distance of 1, 2 spots. Okay? But the reason the blue line looks like it's above it is because it's been stretched. All right, let's look at the example 6. Same thing. Go back to y equals, clear your stuff out. We're going to graph it. Okay? Describe how it's transformed, find the asymptote and all that. So let's graph it first. We've got 3 log of x, close that parentheses behind the x and put plus 5. Now let's look at the table. Let's find the last place we see an error. Again, the last error is at 0, so that means our asymptote is x equals 0. You can go ahead and draw it in if you want to. So right here through x is 0, there's our asymptote. And we can plot some points. We got a point at 1, 5. And let's see. We have a point at 10, 8. I'll go in between them there somewhere. There's a point at 5 and 7.1. Right in there somewhere. If you look at the actual picture, you can see it moving down through here. Okay? So the other items it wants are the transformations. Well, that 3 out in the front, again, just like the one before, it's multiplied. It's in the front. It's a whole number. That makes it a vertical stretch by 3. A plus 5 in the back. Added at the end. Some kind of shift translation. Since it's outside, it's a vertical translation or a vertical shift. And this time, it goes up 5. It's really hard to see how they move from their parent when there's a stretch because that alters the shape of the graph. Okay, but those are the 2 different transformations there. Let's go to example 7. Now, what these want us to do is take what it says, take the parent that it gives us, like for instance on A right here, f of x equals 4 to the x, that's the parent graph. Okay? And it wants us to take it and write a new function based on the transformation it gives us, or transformations. So A says f of x equals 4 to the x is reflected across both axes. Right? So this reflected across both axes, you need a negative outside and a negative inside. All right, and it's moved down 2 units down. So that means you would subtract 2 on the outside. So let's figure out how to write this. And I'm going to write it the new name. I'm going to call it g of x equals. All right, and we're going to go negative 4. That negative on the outside takes care of our x-axis reflection. Now, the negative on the inside's got to go up in here in the exponent, so I need to the power of negative x. That takes care of our negative inside. And then I want to go down 2 units. So at the end, I want to subtract 2. This would be my new function. I should have a reflection over both axes. That negative right there is an x-axis reflection. The negative here is a y-axis reflection. So that's a reflection over both axes. The minus 2 at the end is going down 2 units. So I got all 3 of the items that they asked me for. If I go to B here, it says, let's see, this one is a log. B says log x is compressed horizontally by a factor of 0.5. I'm going to write this as a fraction. 0.5 is 1/2. And that's important because when you compress, that's multiplication. When it's horizontal, it's got to go inside. So it's going to go in for this x right here. Then it says, and move 3 units left. Now, 3 units left means on the inside, you need x plus 3. So I got a bunch of things going on that are going inside. So let's Give it a new name. It was g of x. Let's call it h of x equals. I don't have anything outside, so I'll start with log. Now, if I'm going to compress horizontally, that means I have to flip my fraction. Go back to the table. Horizontal compression. Okay, by 1/3, but when I look over here, there's a 3 in the actual log. So 7b here says compress horizontally by a factor of 1/2. So if I flip that, I need a 2. Okay? So the 2 multiplied on the inside is going to compress it, but what am I multiplying it by? I can't just multiply it by x on the inside because I got to go 3 units left. So I have to multiply it by this parentheses. It's making me go 3 units left. So the 2 here is a horizontal compression by 1/2. The x plus 3 is what's moving me 3 units left. And that would be my final function. All right, we look at C. It says log x is translated 3 units left. So just like the one before, x plus 3. It's got to go inside. It's got to be a plus. And stretched vertically. That's outside. That's multiplied by a whole number, because stretch is a whole number, by a factor of 2. There's my whole number. So I got g of x equals, I got to go outside. I need a 2 outside of the log. And then on the inside, I have x plus 3. The 2 is my stretch. The x plus 3 is my left 3. All right, D says f of x equals log of x is translated 1 unit left. So again, that should be x plus 1. 3 units up, so that's plus 3 at the end. And horizontally stretched by a factor of 5. So if it's horizontally stretched by a factor of 5, I have to put 1/5 on multiplied on the inside. So I got a lot of stuff on this one. So I'm going to name this one g of x equals. There's no vertical stretch, so I'm going to start with log. And I got to multiply a 1/5 on the inside, but I can't just multiply it by x because I also have this x plus 1 inside. So like we did before, I've got to put that x plus 1 inside. So the 1/5 and the x plus 1 are all inside of that big parentheses. And then at the end, I got to go 3 units up. So I got to add 3 to all of that. My 1/5 inside is my horizontal stretch, because we think opposite. My x plus 1 inside is my 1 unit left. My plus 3 outside is my 3 units up.